everyone, very nice to see so many attend. I'm Martina Björkman Nyqvist, and I'm very happy to moderate today's session or today's seminar. And today we are very happy to have Pauline Rossi from Ecole Polytechnique-CREST, who's going to be with us and present our papers on spillovers in childbearing decisions and fertility transitions, evidence from China.
So thank you for joining, and thank you, Martina, for hosting this session. First of all, I want to say that this is a joint work with Yun Xiao, who is here today, and she can help me answering some questions. Yun is a PhD student at the University of Amsterdam, and she's on the market this year. So if you are hiring, please take a look at her file. All right, so the starting point for this paper is the long-standing debate in social science on the fundamental causes of fertility transitions. So why we moved from societies with large families to societies with small families. And an influential view since the beginning of the 50s is that fertility decline is related to economic development, so changes in structural factors affecting the cost and benefits of children. And at the macro level, there is indeed a negative correlation between fertility and development. But then some scholars have argued that at a more disaggregated level, the decline in fertility started at different stages of development. And they propose to think of small families as a cultural innovation that is gradually transmitted through social interactions. And so, of course, it would be easy to present these two views, the structuralist view and the diffusionist view, as a kind of deep divide between economists and sociologists, but they are not incompatible. And several people have tried to reconcile them by combining the rational choice approach of economists with social factors. And the key insights from this model is that it's the interplay between incentives and norms that's crucial to understand differences in historical transitions. So what I mean is that economic preconditions may be amplified or undermined by social interactions, so that the same change in one structural factor may trigger the decline in fertility in one social context, but not in the other. And so an important question in this line of research is trying to understand in which circumstances can we expect social interactions to accelerate fertility transitions. So that's the question that we address in this paper. We want to know to what extent and through which mechanisms do others influence couples in their fertility decisions. And we exploit a natural experiment in China in the 70s and 80s. So this is a time when China introduced very strict family planning policies. So the one-child policy that everybody knows, I guess. And before that, a milder version called the later, longer, fewer policy. And so this is an interesting setting for us because only the majority ethnic group, the Han Chinese, were subject to birth quotas. The ethnic minorities were exempted. And so the idea is to use this shock to the fertility of one group as a partial population experiment to overcome some identification issues. So we will show that the Han respond to the policy by having fewer children. And then we will test if minorities respond as well, even though they don't have to comply with the quota. So this will be informative about spillover effects. So the only challenge remaining in terms of identification is to isolate the causal effect of the policy. And here we do a simple difference in difference, exploiting the fact that the exposure to the policy varies by cohort and region. So we find that minority women reduce their fertility in response to the policy, and more if there are more Han in their reference group. And using an instrumental variable, we estimate that a woman gives birth to 0.64 fewer children if the average completed fertility in her reference group is reduced by one child. So this is a large spillover effect. And then we try to understand why spillovers are large in this context. And we find that the fertility response of minorities is driven by cultural proximity with the Han and by higher educational investments, suggesting that both a social channel and an economic channel are at play. So the paper relates to two strands of the literature. The first one is on the impact of China's population policies. So the one-child policy has been extensively studied. And in fact, the effect on fertility is not so large. And this is because fertility was already low when the one-child policy was introduced in 1979. And demographers and historians have long argued that, in fact, the decline in fertility was triggered by the earlier campaign, the later, longer, fewer campaign in the 70s. And so economists have recently started looking into that period, and they seem to confirm this view. And so that's why in our paper, we use a time period where most of the variation comes from the later, longer, fewer campaign, and not so much from the one-child policy. So in our view, the best identification strategy is the one by Chen and Fang, and it relies on variation in pre-policy fertility levels and the staggered adoption of the policy. And so I will give you more details later because it's the one that we also use in our paper. In the literature, the spillover effects are often ignored. Sometimes the ethnic minorities are used as a control group, assuming that they were not affected by the policy because they were not targeted. So if our results are correct, it suggests that these papers tend to underestimate the causal effect of the policy. But in general, ethnic minorities are excluded from the sample and people focus on the Han Chinese. The second strand of the literature to which we hope to contribute is the one providing empirical causal evidence of peer effects in fertility decisions. And here the focus has been on the timing of births. So people look at whether I have a child at the same time as my colleague, my friend, my neighbor, but they are not interested in fertility transitions. There is one paper that looks at this question from a macro perspective by Spillovers and Vaxiag, and they explain the diffusion of small families in Europe in the 19th century by the linguistic distance to French. So in their context, France is the innovator, and they show that small families propagate first to groups that are closely related to France and then to the rest of the continent. So we come to the same conclusion in the Chinese context when we explore the social channel. So as far as we know, there is only one paper close to what we do by Li and Zhang. So they use a different data set, a different time period, and a different identification strategy. And they come up with a point estimate of the peer effect parameter that is between 0.5 and 0.9, depending on their specification. So our result is 0.64. So it's consistent with their findings, but it's much more stable and precisely estimated. And I would argue that this is because we have a better empirical design. And also we try to quantify the role of spillovers in the transition and to dig into the mechanisms why they don't. Okay, so that's the roadmap. Let me give you a little bit more details about the historical context. So the efforts in China to control population growth did not start in 1979 with the one-child policy. They started a decade earlier with the later, longer, fewer campaign. So later refers to later marriage, longer to longer birth intervals, and fewer to fewer children, so no more than 2. So this is a two-child policy, if you want. And today, when we think about family planning policies, we think of marketing campaigns trying to convince people that a small family is a happy family, or just providing contraceptives for free. But in this context, it was really not like that. It was the government sets a rule, and whether you like it or not, you have to comply with the rule. So in practice, you had some leading groups that were formed in each province to organize the implementation. And not every province started in the same year. So we exploit this rollout for identification. And then from the province level, you go all the way down to the local level to find the organizations that were really in charge of making sure that people comply with the rule. So in cities, these are enterprise and neighborhood committees. In villages, special cadre and barefoot doctors. And then each locality has its own way to make sure that people comply. So some municipalities would issue a third child permit, and they would only grant it to the people who have an exemption, who are exempted from the policy. Other would impose forced abortions, sterilizations, or IUD insertions on the women who are not eligible to have another child. So more generally, this was a period of time where the state had a lot of control on economic lives. In cities, the state would control the allocation of housing and jobs. In villages, of land and food. Migration was very restricted. And so there were many ways that officials could use to implement the policy. And the important thing for us is that in all provinces and throughout the period, the ethnic minority groups were exempted. And so this is clearly documented by historians, and the reason was that the Chinese leaders were afraid that this unpopular policy would push these groups to break away from the central government, and that this could maybe end up in a civil war. And so given the small weight of the minorities in the population, they are less than 10% of the Chinese population, they decided that it was not worth taking that risk. So the one-child policy is just the continuation of this effort, but now couples are only allowed to have one child. Okay, and so these ethnic groups that I've mentioned, in China, you have officially 56 ethnic groups, but one is really dominant. The Han Chinese represent more than 90% of the population. So the others are clearly minorities, but at the scale of China, they still account for millions of people. In the census of 1990 that we used for our analysis, there are close to 100 million people. And the good thing for us is that these minority groups are quite different one from another in terms of cultural integration and labor market integration into the Han society. So I will give you more details when I talk about the mechanism, but on the cultural side, we used linguistic distance and residential segregation to separate the groups into strongly integrated and weakly integrated. And then on the economic side, we used the degree of labor market competition with the Han to separate the groups into strongly competing and weakly competing. So I'll give you a bit more details on this later. But for now, I just want to say that this is broadly consistent with demographic classifications, even though this is a simplification compared to the indices that demographers and anthropologists have created. Okay.
So Pauline, so just one clarifying question from me. There has been some in the chat, but they are answered by your co-author. So a little bit on the Han group, is that the one-child policy that later came as well? Was that also only targeted to the Han, or was it only this policy?
So for the one-child policy between 1979 and 1984 was also all the minority groups were exempted. And then after 1984, some groups started being gradually included in the birth quotas, in particular the largest groups. And so in our analysis, we will focus on cohorts that had stopped giving birth before 1984. So that also explains why we choose a specific time window to make sure that they were not, they didn't have to comply with the quotas.
And the government or the rulers of China at this period was also from the Han ethnic group?
Yes, yes.
I'm thinking more political economy. What would happen if you decide something over a majority group? If you're not.
Yes, so they are from the Han ethnic group. I think only the Manchu ethnic group has ruled China for a small period of time during the history, but otherwise they were always from the Han ethnic group.
Oh, thank you. There's actually one question from Monica Mertz that we can take at the same time. And Monica, you can unmute and ask this.
Yeah, thank you. I would like to know why this later, less, whatever policy focused on the Han only. Is it possible that this group started with a larger initial fertility rate?
So you will see later. No, it's just that they represent more than 90% of the population, and the goal of the policy was really to reduce population growth. So if you target the group that makes 90% of your population, you will have a larger impact on aggregate than if you target smaller groups.
Okay, but just to add to this, but how was it justified by the government to just focus on this large group and eliminate all the others?
Yeah, so my understanding is that this was seen as positive discrimination, if you wish. And so at that time, so what I've read from historians, but I've seen other historians saying that it's not true, so I'm not entirely sure, but that when there was the civil war between Mao and the nationalists, Mao had some alliances with the ethnic groups and said he would create a union of republics, on following the model of Russia, of the Union of Socialist Republic. And so he won the support of the ethnic minority groups with these promises. And so then later he favored them, but on some dimensions, but I've read that on other dimensions, he also broke his promises. So that was part of let's say of a bigger game to win the power. That's my understanding of the history. Okay. So in terms of data, we use mainly the 1% extract of the 1990 census data, and we focus on these cohorts of women born between 1926 and 1945. And this is because these women were in their 30s during the 70s, so they were affected by the policy, and they were older than 45 at the date of the census. And so we can use the question on total number of births as a measure of completed fertility without worrying about the censoring and timing of births. Then for the descriptive, when we look at aggregate levels and trends, we also use the 1982 census and the 2005 mini census to have a longer time window. And so the key explanatory variables of interest are the expected fertility reduction and the local Han share. So I will show you now how we construct these variables and where the variation comes from. So if we start with the Han share, this is the first map here. It shows the share of Han in the population at the prefecture level. And in very light gray areas, the Han are in fact the minority. They represent less than 50% of the population. But in very dark gray areas, they represent more than 99% of the population. And this is correlated with socioeconomic development because the coastal areas are more developed than the inland parts. The second source of variation is the rollout of the policy. So this is the second map showing the year when the LLF leading group was formed at the province level. So it started in 1970 here and here, and up to 1975 here and here. And then the last source of variation is the initial fertility level, because the birth quota is 2 for everybody. So mechanically, the intensity of the treatment will be stronger in places where women were still having a lot of children. There will be a larger reduction. And so here I show the fertility rate in 1969, just before the policy. In rural areas, it varies between 5.5 and 7 children. And in urban areas, it varies between 3 and 4.5 children. So now we want to combine these sources of variation, so the rollout and the initial fertility level, into a single measure of policy exposure. And so I will show you how we do this with an example. So say that we consider the province of Xinjiang in urban areas. If we look at the total fertility rate in 1969, it was 5.27 children. So this total fertility rate can be decomposed into age-specific fertility rates, showing when these 5 children would happen during the life cycle of the average woman. And so then we look at the policy year. So in Xinjiang, the policy was introduced in 1975. So if we consider the cohort born in 1945, for instance, they were 30 years old when the quota is introduced. And so at that time, they had experienced these fertility rates in blue, cumulating to 3.1 children already born. And the average woman would experience these fertility rates in red, cumulating to 2.1 additional children to be born. So we define the expected reduction, ER, as the number of births that will not happen if the policy is perfectly implemented and if there is no change in fertility otherwise. So if in the absence of the policy, fertility rates would have remained constant. So for this cohort, this is 2.1 children. None of these 2.1 children will be allowed because the number of children already born is higher than the quota of 2. So this policy, this number, if you wish, is kind of the maximum reduction that you can expect from the policy if it's perfectly implemented and if otherwise everything remains constant.
Sorry again, Pauline, can I
yes.
ask a clarifying question on that as well? So if you introduce a quota on maximum 2 kids and you already have gone above that quota, so you have already 3 kids, what would the punishment be if you would have 2 more than? You already passed the quota.
Yes, but now you have to stop. So you're not eligible for another child. So you cannot get a permit for another child, or you have to have a sterilization or a forced contraceptive use to make sure that you don't have another child. So you're past the quota. It's not retroactive if you want, but you have to stop where you are.
So I guess what I'm asking is, what would happen if I had, like, what is happening for those that had 3 kids at this point in time when the quota was introduced? Do they sterilize them by force, or do they, like, what would happen to me if I was this woman?
Yeah, so it depends on the localities. But so either you would have to apply for a permit and you would be denied. So if you still have a child, then you could incur a forced abortion, or you would have to pay a very high fine, or you would lose your job, you would lose your house, you would lose a part of your food, etc. So you would be sanctioned in some way.
Okay.
So this measure will vary across cohorts because, as we were just saying, it depends on the number of children that you had already. So for the cohort 1930, for instance, they were already 45 years old. So for them, they had almost all their kids already. So the expected reduction for them is really small. And then it also varies across places so for 2 reasons. First, because the initial fertility level is not the same. So for instance, between rural and urban areas, or also across provinces. And second, because the policy was not introduced in the same year. So if we take the province of Jiangsu, for instance, the policy was introduced in 1973. So if we look at the cohort 1945, now they were still in this age group 25 to 29. So this cell here contributes to the expected reduction, but it did not in this other province where the policy was introduced later. So I can show you now how this expected reduction correlates with the actual reduction. So this is for the Han Chinese, and in black we have the expected reduction that we just constructed, and in gray the actual fertility of the Han Chinese. So you can see that for the old cohorts born before 1925, they are not exposed at all because they were too old. And then the exposure increases quickly in a convex way until cohort 1945, who is fully exposed with an expected reduction of 3 children. And then there is a smaller increase from 3 to 4 children that coincides with the additional exposure to the one-child policy, when the quota moves from 2 to 1. So if we look at the actual fertility now, we see that it's quite stable around 5 for the older cohorts. Then there is a strong decline down to 3 children that coincides with the LLF exposure. And then a slower decline down to 2 children that coincides with the one-child policy exposure. Another way to look at it is to do an event study. Now, instead of the cohort on the x-axis, I plot the age when the campaign was launched. And you can see that the fertility reduction starts being significant here for women who are younger than age 40 when the policy was introduced in their province. And the reduction becomes stronger and stronger as the cohort is more and more exposed to the policy. Okay, so this is for the Han Chinese, but what we are interested in is the reaction of the minorities. So now I show the same thing for the minorities, but now I split the sample of minorities between those who live in areas with a large share of Han and areas with a low share of Han. And you can see that there is, before for the old cohorts, the fertility is around 5.56 children. And then there is a decline, and the decline is stronger for the minorities who live in places with a lot of Han. So another way to see it a bit more precisely is in the event study graph, where I plot here the correlation between the share of Han and the fertility of minorities. So for the older women who are not exposed to the LLF policy, the correlation is 0 and constant. And then the correlation starts being negative for the age group who are younger than age 40 when the policy starts. So the negative correlation between the local Han share and the fertility of the minorities appears precisely for the age groups when the Han start reducing their fertility in response to the policy. And it becomes stronger and stronger as the Han reduce more and more their fertility. Okay, so this is just a descriptive evidence that minorities seem to reduce their fertility as well, and to reduce more when there are more Han around them. So now how can we use this to say something about peer effects? So first, we will take a reduced form approach and estimate the causal effect of the policy. Then we will look at heterogeneous responses to try to speak to the mechanisms. And finally, we will argue that these results are consistent with the standard linear and means model of peer effects. And we will estimate the parameters of the model and quantify the role of spillovers in the fertility transition. So for the reduced form approach, it's very simple. We do a difference in difference, where we regress the completed fertility of women on the expected reduction, so our policy measure. And we control for a cohort fixed effect and a prefecture hukou fixed effect. So hukou is rural or urban. So we allow the prefecture fixed effect to be different for rural areas and urban areas. So just the standard diff-in-diff assumption, we will say that rho captures the causal effect of the policy if, in the absence of the policy, the changes in fertility outcomes across cohort would be the same for all prefecture hukou groups. And we can relax the assumption a little bit by controlling for time-varying controls at the province level to absorb potentially different changes in socioeconomic development. And we can even have a linear time trend that is a province hukou specific and exploit the deviation from that trend for identification. So the first equation gives us the average effect. And now to see if the effect depends on the local Han share, we interact the Han share SH at the prefecture hukou group level with our expected reduction variable. So the advantage of this second equation is that we can directly test for a direct effect of the policy on the minorities. So rho 0 here will capture the effect of the policy in places where SH is 0, so in places where there is no Han. So suppose that the minorities are maybe not perfectly exempted, or maybe they are convinced by the propaganda in favor of small families, or maybe now they have a better access to contraceptives, then this will be captured by row 0. Whereas the spillover part will be captured by phi. And I will show you at the end that phi has a structural interpretation. So if we move to the results, now in the first column, we look at the Han, and we see that when they are supposed to reduce their fertility by 1, they actually reduce their fertility by 0.24. So it's not 1 because the policy was not perfectly implemented, and because fertility declined over time for other reasons that are captured by our controls and fixed effect, but are not directly the result of the policy. So in terms of magnitude, it suggests that 0.8 births, or 50% of the total reduction of the Han fertility during the period, can be attributed to the policy, and then 50% to other factors. So this is consistent with what other papers have found. And so our contribution is to look at the minorities, not at the Han. So that's what we do in column 2. We estimate also a large and negative coefficient for the minorities, but very imprecisely estimated. And this would suggest that there is this average effect is masking a heterogeneous effect. And in column 3, we see that indeed the effect strongly depends on the local Han share. So when the Han share is 0, then we find no effect and the coefficient is small. So we don't see any evidence of... sorry? Is there a question or?
Yeah. So I think, yes.
Okay. Yeah, so in the when there is no Han, we find no response. And if SH is close to 100%, close to 1, then the minorities would reduce their fertility by 0.2 when the Han are expected to reduce by 1. And so in terms of magnitude, the average Han share in the sample is 47. So this means that 0.3 births, or 40% of the total reduction in fertility during that period, can be attributed to the policy. So then what we do in the other columns is try to say, okay, maybe this is not enough to completely rule out the possibility that minorities are directly affected. Yeah.
Before you move on, Michelle has a question that I think we just asked that now.
Okay, so yeah, it's mostly a clarifying question, but since your expected reduction is so important in your regressions, maybe I misunderstood the construction, but it seems like you constructed it based on a specific cohort of women that already had some birth by the time it was implemented. To me, it seemed like too small in some sense, because the expected reduction for those Han women of later cohort should be even larger, because they can't even have these 3 kids anymore and so forth. So I was just wondering, since it's such a...
So the expected reduction, so the 3.3 is for the youngest cohort, so the 1945 cohort. And for them, the expected reduction is 3.3 because they start with more than 5.
For that cohort, I understand, but you're doing this, are you estimating this cohort by cohort? So
ER varies cohort by cohort.
Okay.
And then to quantify, I'm taking the mean and the max and I look at the change in fertility between this very young and very old cohort. And then I can say that 50% for the Han and 40% for the minority of the decline is driven by this coefficient.
I see. Yes. I see. Okay, so I thought you had just one measure of ER, but you have a cohort specific.
No, exactly. We have like all this. So we have all these cohorts. We focus on 1926 to 1945. So this is the youngest, the most affected. And as you were saying, for them, this is the maximum amount. They have to move from 5 to 2. So this is free. Yeah.
Okay, thanks.
All right. So maybe we can discuss the robustness during the during the discussion, except if you have a very urgent question now. But I want to show you a little bit about the mechanisms part. So here we want to understand why people would reduce their fertility when people around them do so. And we have two channels in mind. The first one is an economic channel that relates to the concept of quality-quantity trade-off. So if the hen have to reduce their fertility, they may spend more per child, in particular in terms of education. And this may, in turn, raise the price of a child for minority parents if they want to keep up with the hen, because they expect the hen to, their kids to compete with the hen for jobs, for instance. And I think Michelle has a recent paper looking at formalizing this intuition in the case of Korea nowadays, but we will see that this was already at play in China in the 70s. So here the nice thing is that we can test these conditions by looking at educational outcomes. So we can test whether the hen increase their education, and then among the minorities, we can try to see which ones increase also their education and which one do not respond. The second channel is a social channel, and it relates to the concept of conformism. So here it's the idea that people have a utility cost if their behavior is different from the average behavior in the group. But this mechanism can only explain our result if our empirical groups that we define at the cohort Huku prefecture level is truly a social group. So if the minorities have their own language and they live in their own autonomous village, they go to their own school, then it's not really likely that social interactions would mediate the spillover that we observe in the data. The drawback is that we cannot directly observe which groups have hen in their social groups, because we don't have data on the networks, the social networks of minorities in the 70s in China. So first, the quality-quantity trade-off. Do the hen respond by having more education, and what about minorities? So first, in the panel A, I look at the Han Chinese children. So now I switch from the panel of mother to a panel of children, and I look at whether the children of exposed mother have more education. So in the first column, I just replicate the fertility results. So when my mother is expected to reduce her fertility by 1, my number of siblings reduces by 0.2. That's what we found earlier. And my probability to attend school beyond the compulsory level increases by 1.7 percentage points. And this is around 13% of the mean. So this is consistent with other studies that have used the one-child policy to provide evidence that there is a quality-quantity trade-off in China. Interestingly, this result is stronger in the families where the father works in an education-intensive occupation, and it's much weaker in the other families. So now what about the minorities? On average, they don't respond. On average, we don't see that when the Han are exposed in their reference group, the minorities have educate their children longer. But we expect this channel to only be at play for the groups who compete with the Han for skilled jobs. And so here, that's where the classification that I showed earlier kicks in. We will classify the groups into strong competition and weak competition, depending on the type of jobs that these minorities often have. So if they traditionally specialize in occupations like a cattle breeder and craftsman, or if in their area the job is not dominated by the Han, we will say that the labor market competition for them is weak. But if they traditionally work in occupations that require education and that are dominated locally by the Han, that could be teacher, for instance, then we would consider the competition as strong. And so for those who strongly compete, we find a positive response in terms of education, but not for the others. So what we conclude from this table is that if there is an educational channel, it can only explain the fertility response of this group, but not of the other groups, because for the other groups, there is no change in the price of a child. So now we move back to the women sample, and we look at the fertility response of the mother. Do those who are in the strongly competing group indeed respond more than those who are in the weakly competing groups? And we find that the response is twice as large in the group that educate more their children in response to the policy, as compared to the other groups who have their own traditional occupations. But it's not the end of the story, because for this group, we still find a significant response. So then we turn to the social channel in column 2. And here we classify groups as weakly integrated if they have their own written language and if they live in their own autonomous areas. For them, we don't find any spillovers. But for the groups that we classify as strongly culturally integrated, so they have the Han script, they use the same written language as the Han, and they are residentially integrated, then for this group, we find a very strong fertility response. Now, since we had groups in the 4 categories that I showed you earlier, strong, weak, weak, and strong, weak, we can look at each channel separately. And so we find that for the groups where there is no channel at play, so weakly integrated both in terms of culture and on the labor market, we see no response at all. For the groups where both channels are at play, we find a very large response. And when only the economic channel is at play or only the social channel is at play, then we find qualitatively similar responses. So based on this, we conclude that both types of channels seem to be at play and to act independently of each other.
Actually, Pauline,
yes,
you have to go pretty quick if we're going to have a bit of discussion.
Okay, yes. So I'll do the semi-structural approach in a couple of minutes, and then I can come back to that during the discussion if it's not clear. So now we want to put all these results in a single framework. So we go back to the standard linear means model of peer effects of Mansky, where the fertility outcome of woman I depends on the average fertility in her reference group, Y bar. And the key parameter of interest is theta. So in the terms of Mansky, is the endogenous peer effect. And we call it the spillover parameter. That tells me if the fertility in my group changes by 1, by how much does my fertility change, holding everything else constant. And we know that it's very difficult to identify this theta. And our strategy is to use this policy shock to the fertility of the Han as a partial population experiment. So very, very quickly, you just have to add the policy term in the Han equation. So H is for Han, M for minority. And then you can solve for Y bar. And then the Y bar terms now depends on the policy variable multiplied by the share of Han in the reference group. Delta is the direct policy effect. So it tells you when the expected reduction is 1, what is the actual reduction that comes as a direct consequence of the policy. So then if you plug in this Y bar here into the minority equation there, you go back to the reduced form equation that I showed earlier. And now we can see that the phi parameter, the reduced form parameter, is a combination of the 2 structural parameters, the spillover 1, theta, and the direct effect, delta. So based on this, we see that with the reduced form, it's enough to prove that both theta and delta are different from 0. But if we want to separately identify delta and theta, we have to do an IV. So we have to instrument Y bar by the interaction term SH times ER in this equation. Okay, so I'm gonna skip the details. We can also recover the direct effect. I can explain that later if you want. But so the bottom line here is that when we do the IV and we instrument the group average fertility by our interaction term, we find that minority women will reduce her fertility by 0.64 if the group average fertility changes by 1. And so this is the same as a social multiplier of 3. So the social multiplier would be 1 over 1 minus theta. So this is a very large social multiplier. We can also recover the direct effect delta. We find that it's minus 0.8. So it's 1/3 of the total effect. So again, consistent with a social multiplier of 3. The total effect on the hand is 3 times as large as the direct effect parameter, because it's multiplied by this social multiplier. Okay, so let me conclude so that we have time for the Q&A. So we provide empirical evidence of large spillovers in fertility decisions in China that are likely to operate through both economic and social channels. And we think that it's important to understand this interplay between economic and social factors, both for understanding the past and predicting the future. So related to the past, the general view on the Chinese fertility transition is that policy played a big role. So demographers talk about an induced fertility transition. And here we explain that the policy effect was magnified by social interactions, and that the social multiplier helps explaining how the policy could lead to such a fast change in behavior. And then related to the future, so you probably know that the one-child policy was abolished in China in 2016. Now you can even have 3 kids. When they relaxed the policy, everybody was expecting a baby boom. That did not happen. The fertility is lower than ever. And so there is a lot of pressure on the government to understand what's happening, because China is getting old and they really want families to have more kids. And so one explanation that's consistent with our framework is that China is stuck in a low fertility trap, in the sense that in this model with social interactions, an important feature is the presence of multiple equilibria. And so you can read our results by saying that in the past, the policy triggered the switch from a high fertility equilibrium to a low fertility equilibrium. But now, if you remove the policy, doesn't mean that you will go back to the initial situation, because the new one is an equilibrium. And so it will be self-sustaining as long as the government does not make it profitable for couples to deviate by subsidizing second births, for instance. But so the key takeaway is that these subsidies don't have to be universal. They can be targeted to a subgroup, and then the rise in fertility is predicted to endogenously propagate to other groups. That's it.
Thank you so much, Pauline. Super interesting. So I'm also going to take this opportunity to just, first of all, thank Pauline for presenting and for the discussion and for everyone joining. Thank you so much.
Thanks a lot for all the questions and the really nice comments.